The word dilation, what do you guys think of? What is something you think of when you hear the word dilation? Eyes, right? When you go to the eye doctor, they put those drops in your eyes that are really, really, yes. And your eyes get bigger so they can check into them. Your eyes dilate when you go outside. They'll get smaller if it's super bright, right? The pupils will. They'll get bigger if it's darker so you can see better. That's a dilation, okay? So that's what we are going to be doing today. So let's talk about those things. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation and a scale factor K. So if it's getting enlarged, is it going to get bigger or smaller? Bigger. And if it's reducing, it's going to get smaller. When we say scale factor K, that is the number you multiply by. There will be vocab on your quizzes and tests, so make sure you see how there's these underlined words. Make sure you're studying them for your tests and quizzes. So the center of dilation is a fixed point which dilation is performed with respect to, and scale factor is the ratio of the lengths corresponding sides of the image and pre-image. So just looking at two sides that are in the same relationship. So a dilation with a center of dilation C and a scale factor K maps every point P in a figure to a point P prime, so the following is true. If P is the center point C, then P equals P prime. So, like, if that's your center, like the origin, like 0, 0 is the origin, if that's your center, then it won't move. Okay, is what it's saying. If P is not the center, the image point P prime lies on line, or ray, CP. The scale factor K is positive number such that K equals C prime over CP, and angle measures are preserved. So the lengths changed, but the angle measures are preserved. Like we talked about with your test, you guys had to answer, why is angle not a congruence, right? It's because the lengths of the sides can be different, but the angles can still be the same. So let's talk about the different situations that come from this. So go ahead and go on to the next page. So an enlargement is when a scale factor K is greater than 1. So if you're doing an enlargement, the bigger number or the smaller number needs to be in the denominator. So an enlargement means the smaller of the two numbers needs to be in the denominator, because that makes it bigger than 1. If you're going to do 2 divided by 1, it's 2. But if you do 1 divided by 2, that's between 0 and 1. Do you see that? The smaller number in denominator. So Rob asked a good question. Did you guys all hear his question and my answer? So he said, why does the smaller number need to be in the denominator if it's an enlargement? Because if you think of like 6 divided by 2. 6 divided by 2 is 3, right? Which is bigger than 1. But if you put 2 in the numerator, 2 divided by 3 is a fraction of 1/3, which is between 0 and 1. Okay? Does that make sense? When we're always thinking about this in terms of absolute value, by the way. So the absolute value of that number. So when the scale factor K is less than 1, the smaller number needs to be in the numerator. So it says, find the scale factor of the dilation. Then determine whether the dilation is a reduction or an enlargement. So first of all, remember when we're looking at transformations of any sort, dilations of any sort, P is the pre-image and P prime is the image, right? So we're going from P to P prime. So if we're going from P to P prime, are we getting bigger or smaller? So is that a reduction or a enlargement? So this is a reduction. So we're going to say reduction here, and now we have to figure out the scale factor. So if it's a reduction, the smaller number is in the numerator. So Morgan, which number, 6 or 14, needs to be in the numerator? So that would be 6 over 14. What goes into both 6 and 14? What is the number that goes into both 6 and 14? Go ahead, Olivia. So if we divide top and bottom by 2, that's 3 to 7. So that is your K value. So K equals 3 over 7. That is the scale factor. That's fine. I mess up all the time, as we all know. No, that wasn't a mistake. That was on purpose. All right, so we're going from P to P prime. So from P to P prime, is that an enlargement or a reduction, Jill? So from P to P prime, is that getting bigger or smaller if you go from P to P prime? Smaller, so is that an enlargement or a reduction? And in a reduction, the numerator has to have the smaller number. So, Ian, what is the factor then? The smaller number is 9 over 15. What goes into both 9 and 15? 3, so that's 3 over 5. So we have a scale factor of 3 over 5. So the original is 12, the image is 12, the pre-image is 12, the image is 3. Which is that getting? Is 12 getting bigger or small? Is 12 getting bigger or smaller? Smaller. So Carmichael, what is that then? Also a reduction. And Logan, what would my scale factor be before simplification? Yep, getting smaller there. So 3 goes into both of those, so that's 1 over 4. So we have a K value of 1/4. Questions on finding the scale factor? We didn't do any enlargement, but if it was an enlargement, make sure the smaller number is in the denominator, okay? Let's go ahead and get those finished, and then we'll do some coordinate stuff real quick. All right, so the next one says that coordinate rules for dilation. If P is x comma y, the pre-image of a point, then its image after dilation centered at the origin, 0, 0, with scale factor k is the point P prime, kx, ky. What that means is multiply x and y by the scale factor. So you'll see here that this is the pre-image, and then they multiplied it by the scale factor for an enlargement here, and that gave you the image. So the pre-image changes to the image. So go ahead and plot your points. So you can graph triangle PQR and its image after dilation with a scale factor K. In this case, our scale factor is 4, so we are going to multiply x and y by 4. But first, plot the image. And don't forget to label your points. Let me get rulers handed out to you guys too. Just take one per pair. I need to buy more rulers. They're slowly disappearing, and I don't even know why anybody wants to take a ruler from me, to tell you the truth, but... Or I just don't know if people are breaking them and throwing them away. Either or. I don't really care. I just need to buy more. Okay, so just one per pair, please. Take one per pair. To connect points straighter. Okay, sorry. So if we are dilating the point P by a scale factor of 4, Gabe, what would the new point be? Yeah, do you see the K here? Okay, so good, -8, -4, because of the scale factor there. So Devin, what would Q be? What would the image of Q be? -4, 0. And Austin, how about the image of R? Okay, so we have our dilation. Is this an enlargement or a reduction that just happened there? Enlargement. The numbers are getting bigger because you're multiplying by a number bigger than 1. And don't forget to label your points with the prime because it is the new figure. Sorry. That's what I was trying to do, exactly. All right, questions so far before we move on to the next one? I'm not going to move on until I see everybody's ready, but just raise your hand, please, if you have any questions. Flip to the next page when you're ready, so I know you're ready. All right, so graph quadrilateral PQ, and this should be RS. So let me think here. So this R needs to be S, and this one needs to be R because of the order of it. And then I think this should say SR up here too. Let me just make sure because I noticed that when I was doing the notes. Yes. So it says graph quadrilateral PQSR in its image after a dilation with a scale factor K. So our scale factor is 1/2. So we'll multiply by 1/2. Is that going to be an enlargement or a reduction, Iku? This will be a reduction. So go ahead and plot your points. Don't forget to label them. Never mind, you didn't need to change this one. Just the one up there, down there. That was a joke. Okay, so if I'm doing this here, I'm multiplying both by 1/2. So Carmichael, what would P's image be? 0, 0, because 1/2 times 0 is 0. Hunter, what would Q's image be? 2, 0. Katie, what would S's image be? My new S that I changed. 0, 2. Very good. And what would R's image be, Desiree? R is the last one that I changed. 2, 2. Again, don't forget to label your points. So yes, this is a reduction like Iku said it was going to be. So it says graph triangle PQR and its image after a dilation with a scale factor K of -2. So this is an enlargement, even though it's negative, because the absolute value of the number is bigger than 1. So let's get plotting PQR. Did I plot something wrong? I did -2, 1. Is that what you're about to tell me? Is that right now? Okay, perfect. Thank you. All right, so Greg, if we're multiplying by a scale factor of -2, what would the image of P be? -4, -2. Good. Kylie. The image of Q.
-2.
Good. And Rob, how about the image of R? You're multiplying by -2. Both pieces, yeah. Comma. Perfect. So guys, what did you notice about this one that's a little bit different? What's a little different about this one? It's like flipped or rotated or something of that nature, right? Because like these ones, you could have just like, kind of, if you're like, we're like stretching or shrinking a picture, right? You're just moving it like this. But this one is also rotated, right? What is another rotation that would be like multiplying x and y by a -1? What rotation multiplies x and y by a -1? What rotation does this look like? It's a 180-degree rotation. And if you think about a 180-degree rotation, if you know the rule, it's -x, -y. So does it make sense that if it's a negative scale factor, it's going to be a 180-degree rotation because it's changing the sign of x and y? So that's why that happened that way. Okay? All right. Next one. There's no image on number 5, so we're skipping number 5. Okay, you received a wallet-side photo of your school picture. The photo it should be 2.5 inches by 3.5 inches. You decide to dilate the photo to 5 inches by 7 inches at the store. What is the scale factor of the dilation? So first of all, is this a reduction or an enlargement?
Enlargement.
Good. Is it 5 by 7? So, we have to line up the sides that correspond. Do you see how this is the smaller of the two sides and this is the smaller of the two sides? If it's enlargement, should the smaller be in the numerator or denominator? If it's an enlargement, should the smaller number be in the numerator or denominator? Huh? Denominator. So this one would be 5 over 2.5. So that's the smaller of the two given sides. This is the larger of the two given sides, and as we have already stated by Lindsay, if it is an enlargement, the smaller number goes in the denominator. So those both simplify to 2, so it has a scale factor of 2. So it says, describe the dilation that maps triangle ABC to triangle A prime, B prime, C prime. So first of all, before we do this, is this an enlargement or a reduction if it's going this way? It's an enlargement. So what I would do is I would get some of the points to figure out what's happening here. So this is 1, 0. This is 3, 0. This is negative 2, negative 2, 1. And negative 6, 3. And this one is negative 1, and that one is negative 3, negative 3. So what do we think our scale factor is that's making the smaller one turn into the larger one? What are they multiplying all the points by? Which ones? This one?
Yeah.
Negative 2, 1. It's on the A, so it's hard to see. So what are we multiplying by? Casey, did you say?
What?
Who said the number? Somebody said it. Devin. It is multiplying by 3. If you look at this, 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. Negative, I guess that should say negative 2 there. It's negative 2, 1. Negative 2 times 3 is negative 6. 1 times 3 is 3. So do you see how the scale factor is 3?
It looks like a 7.
Yeah, I don't even know. I looked at it again. It does look like a 7. I have no clue why they did that. I'll fix it now that I'm looking at it. Okay. All right, so that's pretty easy if you don't have to rotate it or anything. But if you have to start rotating, it gets a little bit harder. So we're going to talk about that stuff here now. So many notes today. I feel like it's never ending. All right. So similarity transformations. A similarity transformation is a dilation or a composition of a rigid transformation. So remember, our rigid transformations were translations, reflections, and rotations, and a dilation. So it has to include a dilation of some sort, okay? It either can just be a dilation or can include one of those rigid transformations we learned with a dilation. So two geometric figures are similar if and only if there is a similarity transformation that maps one of the figures onto the other. Similar figures have the same shape but not necessarily the same size. Okay? So let's look at this one. Let's just practice this composition here. So go ahead and graph ABC with vertices A negative 4, 1, B negative 2, 2, and C negative 2, 1, and its image after the similarity transformation. Hayden, if we're doing the translation x plus 5, y plus 1, what does A's image look like? What? Negative 4. There you go. Olivia, what does B look like? Yep. In Harmony, what does C look like? Okay, Helena. So here's another way to write dilation. So sometimes you'll see it as k equals 2. This is more like the transformation. Do you see how it's like x comma y equals 2 times the x, 2 times the y value? So there's 2 different ways you can write transformations. I'll accept both ways. This way is another way we can do it. So it's just saying multiply x and y by 2. So Helena, what would your A turn to? Daniel, what would B turn to? Be careful. We've already done this one. We're on this one. It says multiply x and y by 2. So there you go. You have to go from the most recent one. Cameron, how about C?
6, 4.
Good. And if you're multiplying by 2, is this going to get bigger or smaller? It's going to be a reduction or an enlargement? An enlargement. Thank you, Ian. Okay, once you're done with that, go ahead and flip to the last page of notes finally. Okay, so the next thing we're going to do is come up with a transformation, whether it be a composition or just a single transformation that will map us onto the other one, kind of like we did before. So sometimes the easiest thing to do is look for that scale factor first. So if you can count the side lengths, it's the first Monday of the month, guys. So if you can count the side lengths, I would count them. And we're going from PQRS to WXYZ. Do you see that? PQRS, WXYZ. So PQ and WX are together, and we're getting smaller. So if we're getting smaller, it's a reduction. If it's a reduction, should the smaller number be in the numerator or the denominator? Numerator. So this would be 1 over 3. We're just going to see if we keep getting the same things. If we do 2 over 6, what does 2 over 6 simplify to? So do you think the reduction is a scale factor of 1/3 then? Do you see how you can, if you can count the side lengths, that's one way to do it? I'm going to show you 2 different ways to do it. So, do you see how that could get it, or that gets you guys your scale factor? So our first thing we're going to do here is we're going to say x comma y, 1/3 x, comma, 1/3 y. So if I do 1/3 x, comma, 1/3 y, this is -6, comma, 3. If I multiply -6 by 1/3, what do I get? Helena, -6 times 1/3 is? -2, and 3 times 1/3 is? +1, because it's positive. So this would be P prime here. Then I have -3, 3. Logan, if I have -3, 3 here, and I'm multiplying x and y by 1/3 because I'm going from here to here, what would this become? -1, 1. Morgan, this is 0, -3. If I'm multiplying it by 1/3, what would it become? -3 times 1/3 is? Think about dividing by 3. What's -3 divided by 3? -1, right? And then finally, Hayden, the last one is -6, -3. What does that become? So -2, -1. You guys got to be really careful with your signs there. What letter is that I just covered up? S. Okay. So after you guys get this, this still is not mapped on to the one over here. But it looks like it's the same size now. Do you see that? So what kind of transformation can still be done to get that to be mapped onto the other? Over which axis? So we do a reflection over y. Okay, so the same thing here, except that, do we have any sides we can just count on this one? Are any of the sides vertical or horizontal? No, so do you know how we talked about the center of dilation, which is the origin for us? So D goes to S, but D and S aren't on the line. U and F are on the line. So you see how U and F are on the line? So if you look here, U is 2 away from the center, and F is 4 away. And then V and G line up. So this is 1 or just a half, and G is 1. So we are going from D, the bigger one, to the smaller one, right? So it's a reduction again. So this would be 2 over 4 or 1 over 2. Are those both the same thing? Are 2 over 4 and 1 over 2 the same thing? Okay, so see if we can do this in 1 here. So first we know that x comma y is 1/2 x comma 1/2 y. But notice something here. F is supposed to line up with U. But F is here and U is here. Do you see how it's flipped of each other? Do you see that? What did we say changes signs? Because this is a positive and that's a negative. What did we say we could do to change the sign with the scale factor? Make it, Katie? Make it negative. Do you see how this is positive and that one's negative as well? So we're going to try, and if it doesn't work, it doesn't work. We're going to try negative 1/2 x comma negative 1/2 y. So that's the first thing we're going to do here. So negative 2, 3. Multiplying negative 2 by 1/2 makes it negative 1. Multiplying 3 by 1/2 makes it 1.5. Which is a point down here. 1 minute. What did I do here? Oh, we're multiplying by a negative. Sorry. Negative 1/2 times negative 2 is a positive 1. 3 times negative 1/2 is negative 1.5, which actually puts us right on to S with D here. And S and D are supposed to be lining up. Do you guys see that? So if I'm looking at E next, this is at 1/4. Half of 1 is 1/2 times a negative is negative 1/2. And then 4 times 1/2 is negative 2. So that's negative 1/2, negative 2. So that lines T up with E, which is what we want. F is at 4, 0. Negative 1/2 of 4 is negative 2, which lines up here. And this is at 1, 0. Negative 1/2 of 1 is 1/2, negative 1/2. So you see how that did it in 1? Now, if you don't recognize this, what you could have done instead is say 1/2 x, 1/2 y, and then did a 180-degree rotation. So that's another way of doing it, all right? So if you don't recognize that right away, you can always do that composition instead, all right? Let's try to get this one more done here, just so you guys can kind of see what this is. Okay, so I'm going to plot A, B, C. And D, E, F. So we have to decide if these two are similar using transformations to explain our reasoning. So if we're just looking, first of all, it's a right triangle. So the hypotenuse is the longest side. Which one of these legs is the shorter side? The 2 or the 6? I think that's 6. Is 2 or 6 shorter? It's 5. So 2 is shorter. Do you see that? And then this is 3 and 1, 2, 3, 4, 5, 6. So if we do the shorter sides and we're getting smaller, so that would be 2 over 3 and 5 over 6. Are these equivalent? Are these scale factors equivalent? Is 2 over 3 the same thing as 5 over 6? No. So this is not similar. So you can look for those scale factors. Okay, do not leave until you get the homework.